So I want to convert this integral into polar coordinates. So notice that the first limits are y equals, so we're bounded by the square root of 16 minus x squared and negative 16 minus x squared, square root of that. So that's just going to be a full circle, radius 4. Centered around the origin. And to convince you, you have x squared plus y squared equals 16 for the equation of a circle with radius 4, center 0, 0. So if we solve for y, we get y is plus or minus the square root of 16 minus x squared. Okay, but we have to limit the x from negative 4 to 0. So negative 4 to 0 is over here. So basically on the left side. Okay. So let's look at the limits first. Let's look at the radius r. So r, the smallest r is 0, and it extends all the way up to 4. Okay. So the radius goes from 0 to 4. Now, theta is our angle. We know that this is pi over 2, this is pi, it's 3 pi over 2. So theta is going to go from pi over 2 to 3 pi over 2. A common mistake is to go from negative pi over 2 to pi over 2, but that would just be this right side. So in this case we don't have that, we only have the left side. So that's pi over 2 to 3 pi over 2. And now we need to make the conversions. So x is inside, so x is r cosine theta. And we're going to replace dy dx with r dr d theta. So we can simplify this. It's pi over 2 to 3 pi over 2. 0 to 4. R squared cosine theta dr d theta. And that is our conversion.